Hello, human biology class. Welcome to the fifth, I believe, and final lecture on the lymphatic system and immunity. Certainly an appropriate topic in this day and age. I have talked sporadically about the coronavirus and will do so more when we get to the respiratory system. Just wanted to add a few bits in right here since it's the appropriate topic to talk about. On the screen in front of you is a picture of the coronavirus. You probably have heard from multiple reports, maybe not. It gets its name from a crown-like visage, if you will, that appears around the virus, and it gives it sort of a crown look, and hence the name coronavirus. It's interesting in that it, like other viruses we'll talk about in this lecture, carries its genetic information on a single RNA, on an RNA strand, not a DNA strand, but an RNA strand. And so really that makes it able to reproduce more rapidly. And what goes on is this virus will attach. There's a number of ways it can get in through mucous membranes and so on. But basically, it's going to attach to some cell endothelial lining, some portion of your respiratory tract, or eyes or nasal passages, something like that. And if you remember how that amoeba captured the paramecium, and we were talking about how that's how macrophages would eat up pathogens in the body. Well, similarly, the coronavirus will become encapsulated by the cells of our body, but that's a mode by which it gains entrance into the body. And instead of being destroyed in that process, it actually multiplies as a result of that process. So once inside the body, the coronavirus will merge with cells that it can get into, and it will inject basically its RNA, its genetic information, into that new cell. Now, since that RNA strand is already an RNA strand, it doesn't have to be transcribed from a DNA strand. It can go directly to a ribosome, and it sort of hijacks that cell's own machinery, if you will, and the cell begins to produce viral proteins instead of the normal proteins that the cell would produce if it went through the normal transcription translation process. And so that's something we're going to see with a number of viruses we'll talk about today, but that's one of the ways that the coronavirus gets in. Another important thing with viral infections is viral load. Some viruses require you to be exposed to lots of them before you'll get infected and suffer symptoms. Other viruses require only a slight viral load, like hand, foot, and mouth disease doesn't require very many viruses at all. I've not yet been able to figure out or find out what kind of viral load coronavirus requires, but I do know that it is a bit more contagious than influenza, so I suspect that its viral load, what the number of viruses that you would actually have to contract, maybe isn't as high, but I'm guessing in that regard. I do know that it is not an airborne virus, but it can hitch a ride on droplets. So if somebody sneezes, for instance, and those droplets are propelled or ejected out from that person's mouth, a virus can catch a ride on that. But if the person is simply breathing air and exhales the virus isn't going to float around in the air. And so my wife, as I've mentioned, is a nurse on a respiratory floor. They have to deal with these types of infections, and currently there's not too many coming in, which is good news. We want to keep it that way. But they are under what's called droplet protocol, which means they have to be mindful of spray, like if somebody sneezed, but it's not airborne. She was mentioning the other day that she has to go through 6 hand washings and almost 10 minutes of putting on apparel before she can go into a room, and then about the same before she can come out. So there's a lot of precautions for people working with this, and just want to keep them in your prayers that they remain safe. So that's a little bit more about the coronavirus. Again, more coming on that. Again, my assumption is that you have the notes alongside you that are on Moodle. And if you look at them, last time I left off kind of abruptly with the end of talking about lymphocytes. And so we're going to once again be looking at some issues as we finish up immunity surrounding them. So here's an image from your textbook. Here's B cells, here's T cells, so kind of an accumulated look at those types of lymphocytes. And again, remember, lymphocytes were these types of cells, small white blood cells, not granulated like the fills. We got the fills and the cytes, eosinophils, basophils, neutrophils. They all have the granules, basophils. Those carry the histamine and heparin, if you remember. Monocytes, the largest white blood cell, lymphocytes the smallest, so on and so forth. Okay, so if we look at some ailments that attack, if you will, our own immune system, those are the ones that can really be difficult. And AIDS is one of those. And your textbook talks a bit about the types of AIDS viruses. There's multiple types of them out there. It also is a retrovirus. And a retrovirus means, that's in your notes, but I don't do a great job of defining that. A retrovirus carries its genetic information on a single strand of RNA. And it hijacks a host cell's ribosomes and causes that cell to produce viral proteins instead of normal proteins, like I just mentioned. AIDS is particularly nasty because it attacks and kills helper T cells and macrophages. So here again we have a virus, or here now we have a virus that attacks the immune system itself, and that makes it particularly difficult when we have a pathogen that attacks our body's own defenses. When you have fewer T cells and fewer macrophages, that also means the percentage of suppressor T cells increases, and it has the function of suppressing the immune system. A person doesn't die of AIDS necessarily. They die of a secondary infection because they are more susceptible to infection. There are a number of types of infection. There's a liver cancer, there's a fungus of the lungs that are common for AIDS sufferers to have and to die from. And it can be a difficult thing, of course. There are some countries that really are struggling more than others, if you will. One in particular is Malawi. Here's Malawi right here. Okay. This is Mozambique here, Malawi, so on and so forth, Zambia. Malawi, it's believed that 1/3 of the population is infected with the AIDS virus, and 60% of pregnant women carry that disease. And the problem with that is that 20 to 30, well, quarter to a third of the time, the baby can become infected with AIDS because the virus can cross the placenta. It doesn't always, but it can. Now, a number of you are social workers, and so in this country you need to know what the risks are. Of course, risk of getting AIDS, number one is gay men. That's 63.4% of infections. Dirty needles, 28.6% of the population, so intravenous drug users, that's another big one. But also incidental needle sticks. Those of you working in the health professions, this is something that you're going to experience. Just kind of getting careless and rushed with a needle, and it jabs you accidentally. That's almost 10% of AIDS cases are believed to occur because of that route. So it's just something you need to be aware of, and it's a difficult thing. So yeah, that's AIDS. I wanted to talk about a couple more. Another one is Ebola. That was everybody's concern here 5 years ago or so. And if we look at Ebola virus, there were some images that we maybe remember. This is a look at that virus. Now it's different from the coronavirus. It looks long and slender, but it is also a retrovirus. It's going to carry its genes on a strand of RNA and progress kind of like I mentioned with the AIDS virus. The difference with the Ebola virus is that it enters the body. It again attacks the body's own immune system. First, it attacks macrophages and monocytes now in this case. And it's going to enter them, so again, it's attacking our body's own defenses. It's going to then be carried to the lymph nodes by those particular white blood cells and expand the infection there. And then from there, it's going to attack endothelial cells. Remember, epithelial cells line things. An endothelial cell would line the inner layer of something. If it's blood vessels, which it commonly is, those layers of cells are going to be ruptured and they're going to bleed. And that's where Ebola gets its reputation from. It is a hemorrhagic disease. You hemorrhage. That means you're bleeding. And these people oftentimes bleed that have it from multiple locations around the body, internally and externally. And in fact, that's one of the main causes of death. There's so much bleeding goes on that blood pressure falls too low, and the kidney and then the liver fail. Folks, you're going to hear that again and again. Kidney failure followed by liver failure. Kidney failure occurring because of insufficient blood pressure. Remember that. It will come up again. So the Ebola virus was a big deal. This was a common image because it could be spread so many different ways. Any body fluid, saliva, mucus, vomit, feces, sweat, tears, breast milk, urine, semen. And it could stay viable in a corpse, in a dead body for a while afterwards. And that's why these people are dressed up like this, to avoid infection. Areas, of course, it did spread to the United States. I had an advisee at Bethel who lost a brother to Ebola. It started out along the Ebola River in what was Zaire, is now the Democratic Republic of Congo, and spread. And this portion of the Horn of Africa here, Western Africa here, is where it really had the biggest impact. And it was about, on average, about 50% fatal. In our country, it wasn't as fatal, down to about 20%, and certainly healthcare quality played a big role in that. But Ebola virus was another major pathogen that attacked the body's own defenses. The last one that I wanted to mention, it's actually in your notes a little farther down, but I'm going to mention it here since we're on that topic, is the Epstein-Barr virus. It's a member of the herpes family. Yep, that's a great one. Causes mononucleosis. You probably the vast majority of this class got infected as a child. And kind of similar to corona, how corona isn't as virulent, isn't as nasty to younger people as it is to older people. Well, similarly, Epstein-Barr virus, you may have been infected by it. You may not have even gotten any symptoms or had any symptoms as a result of it. Or if you did, it was just sort of a mild fever and not a big deal, and it passed within a few days. But if you get a later exposure, if you get, it could be a bigger issue. It can actually lie dormant in B lymphocytes. It attacks B cells. So if you remember, the B cells were the ones that produce the antibodies right here. So they get sort of turned on, they turn into a plasma cell. They mass produce antibodies, these gamma globulins, that attach to a foreign cell and destroy it. Okay, so Epstein-Barr virus would attack them, but it doesn't go away once the once the symptoms subside. It can actually lay dormant in B cells without killing them, and it does so along respiratory passages in salivary glands. And when a person becomes stressed and their immune system becomes repressed or sort of beaten down a bit, then they can pop back to life and be in a person's saliva. That's why it's mono is a kissing disease, and it can be passed that way. And so Epstein-Barr virus is another example of one of those viruses that attacks our own immune system. There are other immunosuppressants is the topic we're talking about. Chronic stress is one, and when you are stressed, your body produces too much glucocorticoid. Big fancy word, but I think you may be familiar with it. Glucocorticoid is from the adrenal gland, and it reduces swelling and inhibits phagocytosis, one cell eating another, and it basically reduces interleukin production, which has the effect of turning off the immune system. Interleukin turns on the immune system, so if you reduce interleukin, you're going to turn off the immune system. If any of you have had an itch or a swollen area, you may have bought hydrocortisone cream to put on it. Hydrocortisone cream is an immunosuppressant. It is trying to suppress glucocorticoid. Now, if you think about this, your adrenal glands, what are they doing? They function when you are startled. It's your fight or flight response, part of it, okay? And so in response to that, your body shuts down resources going to all other areas of the body to focus on that fight or flight mechanism. Well, one of the other areas of the body is your immune system. And so when you're stressed, you produce, your adrenal gland kicks in, it produces glucocorticoid, and it basically shuts down your immune system. When you have a swollen area, sometimes, or a rash, sometimes it's because of an immune system response, and so you would put hydrocortisone cream on it. And you're doing the same thing. You're trying to shut down your immune system. In this case, very locally and very specifically, but with glucocorticoids, sometimes they're not that specific. I already mentioned that increased age is itself an immunosuppressant. When I do the pig dissection, I'll show you the thymus gland. There are fewer T cells produced, as I mentioned, because your body assumes you've already been exposed to all the pathogens you need, so you don't need so big of a thymus gland, so it reduces the size of it. And it produces T cells slower. So those are all immunosuppressants, if you will. Two last things I want to finish up with. Allergens is the first one, allergies. And that's kind of a broad category. And it's really, when I say allergy, I'm guessing you think of things like this, which is poison ivy, or like this, which is ragweed. Now, those of you that suffer with these, if you get exposed to ragweed, you're going to probably have a response within a couple of minutes. You're going to start sneezing, potentially have airway irritation, swollen airways, as that normal body response. Basophils go to the area, dump histamine and heparin in there, and the areas fill up. But if you've ever been exposed to poison ivy, it's usually a couple of days before you feel a response. So you know there's some variability here, and allergies are that way. Allergies are really, as the notes say, hypersensitivities to common substances. Some think that there are similarities to pollen grains, to pathogens that you may have been exposed to in the past. There is a genetic predisposition towards being allergic, but it isn't necessarily towards being allergic to a specific thing. So in other words, if your parents were allergic to ragweed, you might be allergic to something else, but you might have a higher chance of being allergic to something. What goes on? So types of allergies. So if we look at that, your body, as I say, produces lots of basophils, mast cells, and antibodies. And really, when you get an allergy, you've already been exposed to it in the past. The word is sensitized, kind of like we talked about with the Rh factor in pregnant women. You get sensitized. So that sensitization, you do not suffer symptoms. You don't swell up, you don't get an itchy rash, you don't have nasal problems or anything like that. It's the next time you're exposed, the re-exposure, that things kick in. Because now you've got these white blood cells that are looking to attack that thing that you've had this initial exposure to. Histamine is released, the capillaries vasodilate, airways constrict, skin becomes red, and so all the stuff I've talked about. These reactions can come in a range. I've already mentioned the ragweed one. Oftentimes an allergic reaction occurs within 12 minutes of your exposure to that allergen. And if it's a food item, those of you know how difficult that can be. It can be an intestinal tract, an upset stomach, throwing up, nasty stuff there. It's not just respiratory. Interestingly enough, those of you that have food allergies, there's a treatment. There's a video I'm gonna try to get posted on Moodle for you to watch. Really important video for you to watch. Very poor quality. My apologies for that. It's the best I can do. This is, and it's a very old video. It's from the early 90s. I'll mention more of that about that at the end here. But if you look at the types of reactions, as I was talking about, some of them are very quick. Food allergies, as I was mentioning. One of the treatments for it now is to have a person actually very slowly eat little bits of the thing that they're allergic to. And the deal is, your body has the ability, your body basically will attack anything that comes inside of it that is foreign to it. Well, why doesn't it do that to foods that you eat? Well, that's because it shuts off the immune response to foods you eat. And so very careful, gradual exposure to these allergens has shown a lot of promise in getting reducing a person's allergic response to food allergies. So that's kind of an interesting treatment, and this video will speak some to that. Well, maybe many of you in the class will say, well, I'm not allergic to poison ivy. Yeah, I said that too. 85% of the U.S. population is allergic to poison ivy. It's just that you haven't been exposed to it twice. And by exposed to it, I mean you have to actually touch and get the oil of the poison ivy plant on your skin for you to have, the second time, for you to have a response. Or you can if somebody's burning poison ivy, you can actually get a response from the airborne particles of poison ivy. It's actually the oils of the poison ivy. You can dilute the oils in a poison ivy, I ought to put a picture on there, in a poison ivy plant 50,000 times and still get an allergic response. Remember, leaves of 3 stay away from me. That's a poison ivy. Commonly confused with the Virginia creeper, which has 5 leaves. That is not a poison ivy. It is not allergic. Poison ivy. So say you didn't know, and you got exposed to poison ivy, got it on your skin. Maybe you forgot about it. A couple days later, this starts to show up. Now the common myth is you can't scratch a poison ivy rash. Well, baloney. The truth of the matter is, if you've washed that area, you've washed the poison ivy oil off, scratch it all you want, you're not going to spread it. If there's still oil on the skin here, you haven't washed your skin in that amount of time, well then, yeah, if you touch the area and then touch another area, you can transfer the oil from one area to another. But you're not going to pop a blister and spread the oil. That's not the way it works. If you are exposed to poison ivy, you know you got in some, you have like 3 or 4 hours. You go throw your clothes in the wash, go take a thorough shower, scrub that area good with some good ivory soap or whatever, and you can avert this sort of a skin rash if you treat it quickly enough. I got it for the first time when I was in my mid-20s in a prescribed burn. I got it in the smoke of something, and I had been in the woods my whole life. So you just never know. But it requires that re-exposure. That initial exposure, you don't get reaction, you don't get symptoms, and then the re-exposure, you get symptoms. Okay, so there are some other types of allergies. There are, like if you got the wrong kind of blood, mistyped blood, that would be considered an allergic response, a cytotoxic reaction. There's autoimmune diseases. We've already talked about some of those. We will talk about some more. Autoimmune diseases like rheumatoid arthritis, that's what you see here, where the body's own immune system is attacking the joints in this person's hand and no doubt elsewhere in their body. Also lupus, a broad spectrum autoimmune disease, most frequently typified by a butterfly-shaped rash across a person's face. These are autoimmune diseases, so there are different types of allergic responses. I wanted to finish up talking about anaphylactic shock. And this pertains back or relates back to what I was talking about with kidneys. If you look at your notes, the bottom line, I'm going to put a picture up here of somebody that this pertains to directly, or pertained to. This is Corey Stringer. He was a lineman for the Minnesota Vikings, and a few years back he died of anaphylactic shock. So what is anaphylactic shock? Well, first, maybe his story. It was August 1st, I think, early 2000s, and the Vikings had a camp, their training camp in Mankato. It was a very hot day, and Corey Stringer is a big man. He was a big man. Said 6'4", 335 pounds. 335 pounds would be a gift. This man weighed over 350 pounds, so he had a lot of body surface area. And so he's out there working hard in training camp, and it's so hot that day that his body, trying to shed all that heat, diverted a lot of blood supply to the perimeter of his body. Okay, so the skin of his body, and that's what your body does when it's trying to shed heat or get rid of heat. And that, in your notes, it says so much vasodilation on the body surface. Vasodilation means the blood vessels get bigger, and more of your blood goes out to the perimeter of your body, the surface of your body. That means there's less blood in the vessels that feed the core of your body, your organs. His blood pressure fell too low. When blood pressure falls too low, the kidneys stop working. I will explain that when we get to the urinary system. When his kidneys stopped working, the clock's ticking. You have a short amount of time, the liver stops working. And then he got these other issues that go along with it, like airway constriction and inhibited breathing. And pretty soon he was dead and actually passed away from anaphylactic shock. So it's a serious condition. Has to do with the circulatory system. It is also a response to I don't know, I guess an environmental condition, but it's related, and so I thought I would throw that one in here too. And it's a good segue to the next topic, which will be the urinary system. Okay. So that's that. A couple more words on the video that's coming. If I can get it loaded. Again, it's a very good video. It's a very old video, very poor quality. The quality gets a little better as you go through, but it will talk about why sometimes the flu vaccine is more effective than others. This is what's currently being worked on for the coronavirus, and so hopefully they're very successful very quickly with that. So it'll give you a window into that whole process. It's going to look at why China and Southeast Asia are where these viruses typically come from. And it's going to look at a couple of other conditions too. It's going to look at schistosomiasis or bilharzia. And that's a very important disease. It's considered the most neglected disease. There's 200 million people worldwide that have it. And it's a big deal. So you're going to get a look at that. And then you're going to look at multiple sclerosis, which is an autoimmune disease. And they'll talk some about that. So look for that video to come. Very important. I will put a sheet on Moodle to attach with it, sort of some highlights of it that I want you to pay particular attention to. And yeah, we'll talk to you later.